Hello, my name is Alexander and I'll be presenting our work on what Clip knows about the red circle. This work was done with Chris Ruprecht and Andrea Dowdy from VG in Oxford. I'll begin this presentation by asking you what you see in this image. I'll let you think for a few more seconds. We feed this image to the zero-shot classification demo on Hugging Face. The demo uses Clip and we provide some possible classes. The top response is a tree, which might be similar to what you found. Now this here is the very same image. The only difference is that I drew a circle on it. What do you see now? If you see an owl, that'd be great, because indeed I have annotated the owl with the red circle. Let's repeat the same experiment by feeding this image to the zero-shot classification demo. Now the image is classified as an image of an owl. When we compare these two predictions, we see that the mere addition of a small red circle on one of them drastically changes the output. However, the important part here is the placement of the circle. It is placed on top of the owl. In this work, we discover an emergent ability of Clip, whereby drawing a circle on an image, Clip's global image representation is focused on the annotated region. In this presentation, I'll discuss this emergent ability of Clip, discussing how we can use that for zero-shot reasoning, why this happens, and what are the ethical considerations associated with this. Now, Clip is a vision language encoder trained in a self-supervised way using text-image pairs from the internet. Encoding an image and a piece of text using Clip, we can get a similarity score. Now let's see how this similarity score can be used. Using prompt engineering, we can zero-shot classify an image. We engineer the possible classes into prompts and have Clip score them, where the prediction is a sentence with the highest similarity score. Prompt engineering has become an important part of interacting with LLMs and vision language models. However, prior methods have mostly focused on text prompt engineering. In this work, we explore visual prompt engineering. Instead of textual input, we engineer the visual input to Clip. Given a referring expression, such as the cup on the right, we wish to find the corresponding object in the image. We annotate all regions in the image and have Clip score all the annotated images. By annotating, I mean literally drawing a red circle on the image. This can be extended to other tasks, such as the task of connecting key points to their names. Given an image with known key points and their names, we wish to match them. To do this, we combine text prompt engineering, assembling all key point names into text prompts, and visual prompt engineering, annotating all key points on the image. Finally, we use similarity scores from Clip to find the matching between the two modalities. Using this simple technique, we achieve state-of-the-art on zero-shot referring expressions comprehension. We even outperform methods that use weak supervision and fine-tune for this task. Below we see some examples where Clip correctly identifies which annotated image the referring expression relates to. We also consider the task of key point localization. Given a key point name, such as left eye, we wish to find its location in the image. We're the first to consider this task and compare to a crop-based baseline, which we significantly outperform. We think this is because cropping a small region of an image removes a lot of context, whereas drawing on the image preserves global information. Throughout this presentation, I've only been talking about the red circle. You might be asking, do other annotations work as well? While the answer to that is yes, here we show that using the color red and the shape circle performs best by far. A possible reason for this emergent behavior that works best with the red circle is the human-centered bias in the dataset. People like to annotate things in images using red circles. A testament to that is a subreddit about images with red circles, as well as the YouTube tutorials with hundreds of thousands of views, showing how one can put a red circle on an image. We explore YFCC 15M, which is part of Clip's pre-training data. We train a classifier in order to find annotated images, and find that in about 0.001% of the data there are such annotations, and I show two of them on the right. The captions of the images correspond to the annotated regions. Below we show an infographic of the annotations we discover. The annotations we were able to mine were all of circles on the left and rectangles on the right. For both shapes, there was a big majority of red ones, as we can see. There is a small number of yellow, blue and green annotations as well. Finally, we find a new type of societal bias in Clip. We show that by drawing a red circle over a person, we made Clip classify them as a criminal or missing. For the image here, we show the ranking of these four classes. In the paper, we show that this holds true for several datasets of real and synthetic humans. We suggest this is because in news articles or police footage, criminals or missing people are likely to be annotated with red circles. To summarize, in this work we discover an emergent ability of Clip, whereby drawing a red circle, we focus the global descriptor on that region. We show the power of that approach by outperforming prior methods on referring expressions comprehension and link this emergent ability to existing annotated images on the internet and Clip's training data. Finally, we find a new bias that likely emerges from the data Clip was trained on. Thank you.